This conference will now be recorded.
Yeah. Guys, did you create any account on this, guys? Okay, not a problem. Just say this, guys. I will show you the how to see the cluster details and what are all the services installed on each node. How many nodes are there? Just I will try to show that first. After that, we shall discuss a simple concept. So I'm going with Ambari. This Ambari will contain the entire details of the cluster, guys. What are all the services installed? That means Hadoop, Yarn, HDFS, Yarn, Hive, Scoop, like this. What are all the components or services installed? Big data tools are installed on the nodes, and how many nodes are there? This entire cluster information. Okay, the entire cluster information will be traced from this Ambari. Okay, so this Ambari is the UI provided by Hortonworks. Okay, and the similar UI is provided by Cloudera, but that is not called as Ambari. That is called as. Can anyone tell me what is the UI called as provided by Cloudera? The same kind of Ambari thing is also provided by Cloudera. It is provided by Hortonworks, and the similar kind of thing is provided by Cloudera. What is it called as? Yes, Kiran, that is called as Cloudera Manager. Remember, like we have Ambari in Hortonworks, we'll have a similar kind of UI in what you call as Cloudera, which is called as Cloudera Manager. Okay, this is in Cloudera. Just remember this terminology. Okay, so this UI will contain entire information of the cluster. Okay, and information of the cluster. Now I will try to show you the cluster. See this. Coming to HDFS, just click. These are all the services that are installed. HDFS, Yarn, MapReduce to this, the Hive, HBase, all these are installed in the what cluster, this cluster. Okay, so this will show that alert, some issue, something is wrong, is happened with this Kafka and spot sets, and these are, but some alerts, they are not totally uninstalled, but there are some alerts. It means there some alerts are there. So go with HDFS. Okay, so in HDFS, as we discussed, we'll have name node, secondary name node, and data nodes. Okay, this already we have discussed. The master processor called as name node, secondary name node, and the slave processor called as data nodes. If you just click on the name node, you'll see the information of this. On which node this is installed. This is the name of the name node. This is the host name of the name node, and this is called as rack. I think already we have familiar with HDFS. They should know what rack is, and this is the number of cores of this instance, the machine on which the name node is installed, and the disk size, memory size. It is 32 GB, I think, 32 GB memory, and this is the average load and remaining information. It's clear, guys. This is about the node where HDFS is, that is name node is running. Okay, and you can see these are all the clients, and along with this HDFS, these are all the services that are running inside this node. In node. This is the node. You can see here is the node information. Okay, similarly go back, and similar secondary name also will be running on some node. And coming to data nodes, let's see this. You can see here there are 3 data nodes. So master is running on one node, that is name node, and data nodes are running on 3 worker nodes. You can see here these are 3 worker nodes. These are the host names. Just clicking on the, okay, this is the one. This is the what you call as host name of the one of the data nodes. Likewise, the entire information, how many cores, what is the memory, what is the load, everything is, you know, everything we can get from here. Likewise, we can know the information of all these. Okay, all the data nodes. Just go back, and if you want to know the information of yarn cluster. Dashboard, go to dashboard. Yeah, from here yarn, here we have yarn. Click on this yarn. So in the yarn, I told you already, we have discussed that resource manager will be the master process and node managers are the slave process or worker. This will run on worker nodes. So if you click on resource manager, it will show you where that is installed. Okay, where the resource manager is running, not installed, run, it is running. And you will see again the node details, everything, all the details here. Okay, fine. Just go back.
The resource manager and name node both are running in the same node, right?
Yes. Generally, node name node and resource manager, they run in the same node. It is not always same, but here the cluster is set up like this. So from here, from this Ambari, how to trace? If we have multi nodes cluster, we do not know where, we might not know where name node is running, where resource manager is running, where Hive is running. We might not know all these details. So how do we trace out? So we can trace out directly from this array. Okay, and coming to node managers, now node managers will be running on the three instances. What are the three worker nodes we have? On the same three worker nodes, these node managers are running. Okay, likewise just we can trace the details. And coming to Hive, you see this Hive, we have Hive Metastore and Hive Server 2. I think you have remembered this. Hive Metastore and Hive Server 2. Hive Metastore, this is where actually Hive is installed. This is the meaning of it. It is running on the server. This is the server, or this is the node where it is installed and where it is running. Okay, likewise just try to understand all these concepts. Okay, why? Because when we are writing any application in the cluster, in order to move the data from here and there, HDFS to Hive to some Spark or something, we should know the host names. Without knowing the host names, it is not a local host, it is not a single machine, right? It is a cluster. So in the cluster, we have to we should know all the services running inside every node. Then only we can understand it. Okay, just see the list of all the nodes here. The dashboard. Okay, just I will try to open the web console. Let me go with the logins and password. We got this. Okay, can you see this here? What is the node I was given access to? You can, otherwise you can simply type host name. This is a host name. See the number here, IP address 172.31.38.146. Okay, to this node I got connected to. So 146. Just see whether we have that in this Ambari or not. 146. Or we can see something called as host here. Can you see this now? Dashboard, services, and host. Click on this host. This will give the information of all the nodes present in the cluster. All the nodes. Nothing but each node is called as a host here. So I was given access to this 146 node. You can see here 172.31.38 146. Here we have that 146, the third node. So I got connected to this. Okay, I got connected to this nodes. So remaining all the three nodes. So totally in this cluster, one master node, that means with respect to HDFS and yarn, one master node and three data nodes are running. Got it? Is it clear, guys? Any questions here? Okay, if you say about in the interviews, if they ask about which distribution you worked on, okay, so they will ask these questions. What is Ambari? How do we trace out the list and everything? Okay, and this is the version of HDB. This is not a version of Hadoop. This is not I'm telling you, this is not a version of Hadoop here. Okay, this is Hortonworks version. Like we have Cloudera 5.13, 5.8, like that, isn't it? So like that, we have Hortonworks versions, okay, releases. So this is the version of Hortonworks, HDP 2.6.5.0. And in the first node, in this node 247, how many services are running totally? 49 services are running, including master process, slave process, everything. Totally 49 components are running. In the second node here, in this 141, 30 components are running, 24 components and 19 components. Likewise, we have to understand about the cluster, guys. And this is the course, the RAM, course, RAM size, disk usage, and this is the rack, IP address, and the average load, and the versions and the components. And if you click on these components, you will see what are all the components running here. This is the list of all the components. Okay, just we can understand all this from here. Is a clear guess about this cluster and everything? Right. Just go to dashboard
Sir,
and
we can submit the job to any one of the node, right? Not only name node and master node. We can submit to
yeah,
data node also,
yeah,
right?
yes,
Yeah, thank
from
you.
any node. That's what I'm telling. See
Thank you.
there, in the yarn node managers, right? Here we have three node 146. 146 is one of the node managers. Either we can submit from master or we can submit from any of the nodes, any of the worker nodes. You can see
Sorry, if
this.
I submitted
I
to worker node.
Yeah, and some SW we have seen, right? Spark submit we have seen, right? So this is the node 146 is the node from where we have submitted Spark submit script. Where do we have it? Is it a master node or slave node? 146 is the slave node. You can see here is a 146 slave node. So you can submit the jobs application from any one of the nodes, any node. But we should know where that, even that is not required. Why? Because internally that will be configured. Everything will be configured. We not worry about that. Ekanchana submit change
Yeah.
from any node, master or any of the slaves. But that must be installed on that. Spark client must be installed on that. Otherwise, we can't do that. Okay.
Sir, my question is, if I submit to any one of the worker node, okay,
Mm,
Spark job, okay, then
mm,
I submit in the cluster mode. So then
mm.
where the driver will launch in worker node or in master node?
No, no. It might suppose say that we are submitting from master node. Let's say you're
Hmm.
submitting from master node in client mode. The driver program will be launched in the master node only. In the same node, simply very simple like this. Driver program will be launched in the node from where we are submitting the application.
Okay.
Will be launched locally in the sense in the node from where we are submitting the application.
Oh,
That is
that is
in
client. Hmm.
client mode. Okay, and the cluster mode is we submit the application the driver program may be launched in this node or any other node. We cannot
Okay.
guarantee that. We
Yeah.
cannot guarantee that. That is the
Okay.
cluster mode. Okay, that
Thanks.
runs in that will be launched in any one of the nodes. Okay,
Okay. Right.
I will try to show that here today, but the only thing is these CloudX people, they have you know what, they have blocked the UIs of yarn and this HDFS. Actually, here we have quick links. Can you see these quick links here? Name node UI. If you could trace this name node UI and this yarn resource manager, we could have seen what are all the services, what are all the applications running actually. But it's not a problem. Still, we can trace it from Hue. Have you heard about Hue? HUE Hue. HUE. This one. Na reply na HUE ainadi. Okay. Don't worry much about it. Just okay. Ambari. Just know about. Just try to know about Ambari. This is on because you may get confused. So Ambari, what is Ambari? If someone asks you what is Ambari is, it is a UI. It is a UI from where we can trace the entire information of the cluster. Entire information of the, it is a UI, okay, user interface. Okay, from where we can trace out the entire information of the cluster. This is what you have to tell. Okay, and coming to the this one, I already think we console. This is where we work actually. Okay, so we'll be connected to any one of the nodes, and we will be we can submit the job from any one of the nodes. This is what we are going to see here. Okay, and this session we shall discuss a simple concept, that is, I think we missed that concept on that day. We did not discuss. Just guys, if you have pen and paper with you, please take pen and paper. Okay. Why? Because we are going to discuss the concept called as combined key we missed on that day. So to understand this, we should understand, already we have discussed about group by key, and one more is, what is another one? Reduce by key. This is one group aggregation operations, and fold by key and aggregate by key. Okay, these all we have discussed, but we did not discuss about this combined by key. Okay, this is a different operation. It is very effective operation, very effective operation compared to remaining operations, remaining uh, aggregation operations. How it is going to work, it's very important. So just to take pen and paper, have pen and paper with you guys. Okay, but because while I'm writing here, you should also write, and then only will understand. Otherwise, you will be thrown into the confusion. Okay, just be ready with that. We are going to start the discussion about this reduce fold. Already we have discussed it, but I will give you a review of this, and I will start discussing about this combined by key. Okay, just take pen and paper and be ready with it. Fine. I'm going to start the same Jupyter here, or you can use Jupyter in your machine, the same machine. I will go with my local Jupyter. We don't need this cluster today. We're not going to discuss about it. We shall complete this part, this simple concept today. From tomorrow, we are going to discuss purely the use cases, where we are going to see totally, we are going to develop the applications, we are going to deploy the applications. Okay, that we'll learn.
Sir, you were telling like hot and works and cloud. What are those, sir?
You know what? If you want to buy something, if you want to buy a mobile phone,
Okay.
whom do you approach? షాప్కి వెళ్తాం కదా, షాప్కి
Yes.
వెళ్ళి we we have same Android phones manufactured by different companies. Which one you will choose? That's up to us, right?
Yes,
So
sir.
Cloudera and Hortonworks, we have one more called as Mapper. Cloudera, Hortonworks. We have one more called as Mapper. These were very popular actually. Mapper, IBM Insights, and even Microsoft has big insights now. Most of the people are providing these services now. See, these are called as the distributions. Distributions. అంటే Cloudera is one vendor. వీడొక vendor. Cloudera is one vendor who is selling Hadoop services to the industry. ఇప్పుడు నేను I want a big data setup. I want a big data setup. ఇవన్నీ నేను ఇన్స్టాల్ చేసుకొని కాన్ఫిగర్ చేసుకోవాలి in my company. Then can I do on it on my own? Can I do it this on my own? I want to set up a Hadoop cluster. Can I
Okay.
do this on my own? So మనం చేయొచ్చు, but you know what? Uh, we have. Can we download Hadoop, Spark, and all this from Apache? Is it possible? Apache ఉంది కదా. We have Apache, right? These are all the
Yes.
products are now open source community. Okay. we can download from Apache and we can set up a Hadoop cluster. That's fine. But Apache doesn't provide any guarantee or any support if there is any issue in any of the components. Suppose Spark lo manaki issue vachindఅనుకో, suppose we are not able to trace out what's happening with that Spark. No one in our company is able to do that. Then whom we have to ask, whom we have to consult? There is a open source community. So రావచ్చు రాకపోవచ్చు answer. But if you go with the Cloudera, they will provide a licensed version, licensed all the licensed tools, and moreover they will provide service to us. మనకు రాలేదు అంటే ఏమవుతాం, if we are not able to do something, then if we ask the Cloudera people, they will come and help us how to do that, everything, installation, regarding installations, regarding working of something, everything, the service will be provided from Cloudera. That's it. It is very simple. ఎట్లాగంటే we have many open source softwares and licensed softwares. What is the difference between open source and licensed?
Open source means free. We can download it and we can use it, but there will not be any support.
Perfect. That's the same thing. With Apache, we can do that kind of thing. With Apache, we can get all the big data tools. We can download them, we can install them, we can set up a cluster, but there will not be any support for us. So Cloudera and Hortonworks వీళ్ళంతా ఎవరు అంటే they are making money out of these big data tools. అంటే వాళ్ళు ఏం చేస్తారు, they are providing an environment. They will if we have to pray to the Cloudera or Hortonworks, one double page చేస్తే they will come to our location and they will depending upon our requirement, they will set up a cluster and they will provide the support. Depending upon the contract period, they will provide the support to us. So we'll name antarante distributions. We call them as generally distributions. Okay, which distribution we have used in your cluster, big data cluster aduguతారు general గా question. So కొందరు ఏం చేస్తారంటే Cloudera, some people say Hortonworks, Mapper, different అందరూ all the companies need not to purchase only Cloudera, right? Hortonworks, right? Depending upon their interest, customers అంతే, all these are vendors. ఎవరు నచ్చితే వాళ్ళది కొంటారు, depending upon the pricing and everything. But Cloudera is the first vendor. Cloudera అనేవాడు, he was the first vendor to sell these services, to sell Hadoop services as a distribution. So that is the reason Cloudera has become popular. But nowadays the Hortonworks has become very very popular compared to Hortonworks, sorry, Cloudera. Okay, Cloudera తో కంపేర్ చేసుకుంటే Hortonworks పాపులర్ అయింది బాగా, because they are providing more services, more flexibility, more usage, and the UIs and everything, they are very very simple to understand in Hortonworks compared to Cloudera. Okay, likewise Mapper is also one more distribution. Is it clear? Vilanta vendors, simple say vendors, but instead of calling them as vendors, we use a word called as distributions. Hadoop distributions or big data distributions. Is it clear now?
Yeah. So it's this AWS and CGP, all these are like we go and work on cloud, right? Whereas these people will do set up at our locations. So that is the only difference.
Perfect. So what is AWS is, these are the cloud services. Okay, these are the cloud services. So cloud services are the remote, somewhere in the remote. What services can provide? What services can be provided by the cloud? ఎట్లాగంటే suppose if you go to some company, let's say we are working for some company. So does the company provides laptops or desktops, or do we need to carry our laptops? It is something
Company
like,
only.
okay, company. So AWS something like cloud service ante they can provide hardware as well as software as the services. So remote location నుంచి ఏమేమి వాడుకోవచ్చు అంటే I can use hardware as well as software. Both I can use from AWS. I want to use one machine. ఇప్పుడు నా దగ్గర I don't have any sophisticated machine. నా దగ్గర high RAM లేదు, 8 GB RAM, some హార్డ్ జీబీ ఇంత లేదు. సో I'm not able to afford to buy a new laptop. Then what should I do now? So these people are providing one instance to work from remotely. So అక్కడ ఒక మెషిన్ ఉంటుంది, ఆ మెషిన్ కి they will give access remotely. Now we can connect through internet and we can work in that machine. మన వర్క్ చేసుకున్న తర్వాత క్లోజ్ చేసేసుకోవచ్చు. సో దట్ ఈస్ మెషిన్స్ ఆర్ హార్డ్వేర్ ఈస్ ప్రొవైడెడ్ యాజ్ సర్వీస్ అండ్ as well as software also. What software you want? What software you want in AWS? I want big data. I want big data tools installed in some machines. Okay, so itla unna requirement. I need a cluster of big data. ఏమేం కావాలి చెప్పండి, ఒక బిగ్ డేటా క్లస్టర్ ఏమేం కావాలి? వాట్ ఈస్ ఇట్ రిక్వైర్డ్ జనరల్లీ? We require machines, right? We require machines. Machines are needed. Hardware, there is hardware, and along with it, Hadoop, all the Hadoop components, right? Like Hadoop, Hive, Spark, Pig, all these are installed. You know, these are the softwares. These are the softwares, right? Okay. So దీనితో పాటు Java, Python, all these are required, right? Java, Python, ఇవన్నీ కావాలి మనకు. Okay, and moreover, what operating system is required? Linux operating system. Okay, and ఈ machines లలో what is required, operating system is required in all of these machines. Generally we go with Linux operating system. Okay, machines in which Linux operating system is involved and these tools must be installed already. దీంట్లో ఇన్స్టాల్ అయ్యి ఉండాలి వర్క్ చేసుకోవడానికి. So this requires to set up a cluster. So if you go with AWS, we can create నాకు ఇది కావాలి, I want some 20 nodes which are of Linux machine and with all these services components running inside those machines, అంటే we can create within few minutes. ఒక 5 minutes అన్ని క్రియేట్ చేసేయచ్చు. That means they provide machines, operating system in them, and as well as the components also installed already in those. Just we can access them remotely. ఓకే, ఒకప్పుడు అంటే ఓన్లీ హార్ట్ అండ్ వర్క్స్, క్లౌడెరా ఇవి మాత్రమే ఉండేవి. అండ్ AWS, GCP and even Microsoft also provided that. Microsoft Azure, we call it as Azure. The cloud service name of Amazon, they named it as AWS, and Google has named it as GCP, Google Cloud Platform, and Microsoft has named it as Microsoft Azure. Okay, and ఎలా ఉంటుందంటే there are phones, mobile phones from branded mobile phones are there, and local mobile phones also there, isn't it? Branded mobile phones like iPhone or Samsung or some phones are there, branded phones are there. Likewise, a branded phones తో పాటు we have local made phones, right? ఉన్నాయి కదా కొన్ని లావా అని, ఇంకేవో ఉంటాయి, some carbon అని, local mode. So if you compare this, the price changes from a branded phone from a local phone. Got it right? ఒక branded
Yes.
phone కి ఒక local phone కి difference in pricing లో. So the quality will be different, the service will be, the type of operating system, the manufacturing style, everything will be different. The same thing here. AWS, GCP branded అనుకోండి, like they treat them as branded services. So whatever they are charging too much, ఎందుకంటే they can give that much flexibility and they can give that much those number of services with high guarantee, high reliability. The services will be efficient. So because of that and because of their brand name, they are charging much. But what I done is I have created, even this Cloudix Lab is one of the vendors, okay, but it is local one. It is not that popular as this one. దీని వీనంత పాపులర్ కాదు, ఏదో చిన్నది. సో ఇట్ ఈస్ ప్రొవైడింగ్ విత్ లెస్ ఫీ టు వర్క్ ఆన్ ఇట్. మనం చూసే ఇన్ వన్ ఆఫ్ ద సెషన్స్ వీ హ్యావ్ క్రియేటెడ్ వన్ cluster on GCP, and we have seen that there we have created cluster, Hadoop cluster or big data cluster. So they are charging there, but these people are not charging. And they are providing some free trial and something like this. There's a difference, ఏది వాడతాం ఏది వాడొద్దని దట్స్ అప్ టు us. బట్ దిస్ కైండ్ ఆఫ్ క్లౌడ్ ఎక్స్ ల్యాబ్ ఇవన్నీ జనరల్గా ప్రొడక్షన్లో యూజ్ చేయరు. వై బికాజ్ ఇన్ ప్రొడక్షన్ వీ రిక్వైర్ హై ఎఫిషియన్సీ, రైట్, హై వర్కింగ్, హై కాన్ఫిగరేషన్ మెషిన్స్ ఉండాలి, హై ట్రస్ట్ ఉండాలి, బాగా నమ్మాలి. సో మోస్ట్లీ నౌ ది కంపెనీస్ ఫర్ ప్రొడక్షన్ మెయిన్లీ దే గో విత్ వాట్ దిస్ ఎన్వైరన్మెంట్స్, దిస్ క్లౌడ్ providers, AWS service, Microsoft Azure. Is it clear now?
Yeah, yeah, yes, sir.
Yeah, guys, please do understand this, guys. Try to understand here. The discussion is going to be very important. You will take pen and paper, guys. I'm not making a joke, guys. I'm not doing it. Please have a pen and paper. And now we are going to see one by one function here. Okay, and we are going to concept one. If you understand this concept, you will feel very, very satisfied. Okay, yes, it is. First, I'm trying to create one list here. L1 equal to A comma sum 10. Next, B comma sum 20. And next, C comma sum 30. Next, A comma sum 30. Next, I'll take one more A here. Take some B. Let me take some elements here. So to call it as a pair RDD, I'm taking the elements as pairs. 15. Next, I will take some 1, 2, 3, 4, 5, 6, 7. Some 25. Take one more B. Some 30. Take some C. Yes. 15 and 25. Take some more elements here. 1A and B. Okay, so I have created one list with some sort of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements are there here totally. Okay, so I will try to create one. Sorry, we need to first create Spark session, right? Cell above. Import Spark session. Spark equal to Spark session dot builder dot master dot get or create. Okay, Spark, just let's print the Spark. Let the Spark driver be created. That is getting created. Yeah, it got created. The Spark it is. Just clear the output. No, fine. Now I will have to create RDD out of this list, guys. Can you tell me how? How do I create RDD out of this list? RDD out
Use
of huh? Huh? Yes.
parallelize method.
Yes. Spark dot
Analyze.
spark to context dot parallelize. Parallelize of L1. I go with three properties. Sorry, three partitions. Okay, and I can print R1 dot collect. Parallelize. Parallelize. Okay, we got this data. Now I would like to see what is the data that is present in each partition. How do I do it? I would like to see the data present in each partition. We got divided 12 elements into three partitions. With these three partitions, you can see three partitions here. Okay, so I would like to know the elements present in each partition. How do I know it? What is the
Map
function that we use?
partition.
Yeah, perfect. We use map partition. Okay, we got three partitions. Now see that R1 dot map partitions dot, so not dot here, lambda x. So here x represents each partition. Okay, x represents each partition. Remember that. Do one thing. I have to write a function here. Df sum f1 of x represents list of x. So I call directly f1 of x. Let me print this. R1 dot map partition f1 dot x.
Go for yield, sir. List instead of list, yield.
Yes, yeah.
Generate list.
Yield a list of x. Sorry. A second. No, we got yield of x and f1 of x. Is it fine? Anything else? Do we need to do this? Yield of x. Mm, invalid syntax. What did we see this? 1 second. F1 of x. Is it yield or anything else list? F1 of x. That's fine. We are listing this. Well, let me try one thing. List of x. 1, 1, 2, 3. Invalid syntax. Do you write anything, any extra brackets here? One map partition. So it is printing only the RDD. Okay, we got the data. I think now we got the same data only, nothing else. But R2 as it is. No. List of Did you miss anything here? Invalid syntax print r2 dot connect.
Sir, is it yield list or just yield? Is it
Yield list.
yield list?
Yes, that's, I think that's what I'm looking for. Yes, now it's fine. Okay, yield a list of x. That's what I'm looking for. Yeah. See this. These are the elements in the first partition. So 4 elements, and these are the elements in the second partition, and these are the elements in the third partition. Okay. Now insert one more. I'm writing a simple function here, that is result1 equal to r1, just r1 dot reduced by key of lambda of x comma y colon x plus y. So what's happening with this? Can you tell me guys here? Result1 dot collect. Yes, we got this result.
First,
Yeah.
grouping
What's
is done
happening here?
within
Yes.
group
So
grouping in within partition, applying the
mm,
function, and then between the partitions again grouping and
perfect.
applying
Perfect.
the
That's
same
perfect.
function.
Yeah, perfect. Now this is a function, right? This is a function. Okay. And where this function is getting applied, on the keys or the values?
On the value.
On the values. Okay, this is very important guys, please try to understand. This is very important. Just I will copy this. So this is the first partition, this is the second partition, and this is the third partition. So total we have 3 partitions. Okay, so what is that we are writing here? It is reduced by key of lambda of x, and we are writing x plus y. Okay, x comma y. So either a function, this function is getting applied on the grouped values. This getting will be applied on the grouped values. So coming to the first partition, how the data will be grouped here? Can you tell me? Here we have a, and what are the elements that will be grouped according to a? 10, 9, 15, right? 10 comma 15. Okay, so this function is not going to do the grouping. I'm telling you, this function will not do the grouping. After the grouping is done, this function will be applied on the grouped values of each key. Okay, that's what I'm trying to tell you. And for B, what is the data? Or 2 elements we have, 10, 9, 20. Okay, this is the grouped data for B. Okay, so similarly in the second partition, that is grouped like this. For C, we have only one for C, that is 30. And for A, again we have 2 more, 30 and 20. And for B, we have only one, that is 10. Okay, and in the third partition, we have C with the 2 values, one is 15, another is 25. And for A, we have only one value, that is 25. And for B, we have only one value, that is 30. Okay, so now the grouping is done. Grouping is done in every partition for every key. Okay, this is the grouping of the data according to based on the keys in the first partition. This is the same thing in the second partition. This is what in the third partition. Okay, now the function, whatever we are writing this function will be applied on the grouped values. Okay, so we write now a comma, and 10, 15 here are there, right? Not only just 2 values, there can be 3 values also guys. There can be 3 values, any number of values can be there. So this function x plus y will be applied repetitively, recursively on all the values that are grouped here. Here we have only two values. Don't misunderstand that x plus y we are performing addition of only two numbers. No, if we have some 10 or any number of values like this, okay, so recursively this function, addition function, will be applied to all the values. Are you able to understand this? This is the first thing you need to understand, guys, here. Okay, so recursively the data will be applied, this function will be applied to, this is very very important, guys. I'm telling you, recursively this function will be applied to every element. Got it? Remember this point. Otherwise, so what is going to happen here? 10, this is the first element, plus 15, that is x plus y. 10 plus 15, it is going to give it as 25. And b, it is going to give it as what? 30. 10 plus 20, it will give us 30. Similarly here we have c as only one element, 30, and b we have only 110, and a we have two elements, that is 50. Is it fine? Now again, here we have c equal to 40 and a as 25 and b as 30. This is what, so this is what that is done at each partition. Okay, each partition. Now the same function, whatever the function that is there here, the same function will be applied after the data is grouped across the partitions. This is the data, these are the two elements. Let me copy this too in the first partition, and these are the three elements in the second partition, grouped, and this function is applied in each partition. That is the result of this. Okay, this is the result of the first step. Now again the data will be grouped. Now after this the data will be grouped. This is the result of first partition, this is the result of second partition, that is grouping and applying the function. Okay, now after this the data will be grouped now across every part, all the partitions. So a 25, and in the second partition, do we have any value of a? Yes, we have 50, and in the third partition we have a equal to 25.
25.
So one more 25 also will be included here. Next, coming to b, in b we have 30 in the first partition, 10 in the second partition, and 30 in the third partition. Okay, and for c, in the first partition we don't have anything, second partition we have 30, and third partition we have 40. Okay, so now this function whatever we have written here, this function applied to even these grouped values also, even these grouped values. Here we have three values, so repeat it recursively, the function will be applied to all the values. So we get a comma 25 plus 50 plus 25, it is going to be 100, isn't it? Next here it is going to be b comma 30 plus 10 plus 30, 70, and likewise for c it is 70 again. This is how the result will be calculated internally. Okay, this is how the result will be calculated internally. Got it? A100, B70, C70. Just verify that. You can see this A100, B70, and C is also 70 here. This is how the result is getting computed. Okay, the very important thing we need to understand here is this is the function that is going to be applied on the values, not on the keys. Okay, it is not going to apply on the keys, it is going to apply on the values. That is what you have to understand, guys, here. Okay, so in reduce by key I write here, what is syntax of reduce by key? Reduced by key, okay, it is some PairRDD. We have to apply this on some PairRDD dot reduce by key of what do we have to mention here? We need to mention a function. Okay, this function f1 will be applied, what we have discussed, but applied on the values, not on the uh, keys. Okay, remember that, not on the keys, it will be applied on the values. Got it? Fine. Instead of mentioning the function here, I can write here, create a function, let's say f1 here, f1 of x comma y colon return x plus y. Okay, now I can pass, instead of x plus y here, f1 of x comma y. I can provide like this. Can you understand this one? Then just instead of writing the logic here itself, I'm writing the logic in a function here, f1, and I'm passing this x1 y x comma y to the function f1. We get the same result. Why? Because we are doing the same operation right here. And if you want to perform subtraction, you can do the subtraction from here. If you want to perform multiplication, you can specify anything whatever you want. So this is the good way of doing, actually. This is a recommended way of doing things. So writing a function and using that function inside this is the good approach. Fine. Is it clear, guys? Any questions here in this? Fine. Next, I'm trying to go with the next function called as fold by key. PairRDD dot. What is the syntax, guys? Do you remember fold by key syntax?
Zero value and
Zero value
function.
comma function. That's it. Sorry. Zero value and function. So we'll have only one function. Okay. And here I have to write something here on the values at within the partitions and across the partitions. This is what you have to do. The same function will be applied within the partition and across the partitions. Here. Now I'm going to show this fold by key operation. Just let me show you that. Okay. The syntax fold by key of, I'm taking some 2 as the what you call as zero value, and function lambda x comma y implies x plus y. Let me first compute here, after that I will write the explain here. So result 2 equal to r1 dot fold by key of some 2 and function. Can I use function for this f1 here, x comma y colon, I can use f1 x comma y here, and print res2 dot collect. Okay, we got this data here. So I have used here multiplication. Let me use addition. Yeah, we got the result. Okay, this is important, guys. Be careful now. Try to understand how this zero value is working. This is where we not, if we understand this thoroughly, then only we can understand the combined by key. Otherwise we cannot understand. Please do understand that. Okay, fine. I'm taking all these values here. Just I will edit this instead of writing everything again. This is very important. Please consider carefully here. What's the role of this? You know what? this zero value is. Okay, find here a comma first element is 2. The first element will be 2 here, that is the uh, zero value. Okay now, and the second element will be 10, and the third element is 15. Got it? So this zero value will be included in the function actually. So but the data will be grouped here first with this 2, 10 and 5, and followed by the next element. What is that we have here? B of again 2, 10 and 20. This is what that is going to do here. So for each key, okay, in each key this zero value is also included. Got it? In each key the zero value is also included. This is what you need to understand, guys. Here c comma, here we have only one value of c, 2 comma 30. Okay, next a comma again 2 and 30 and 20. This is about a. Next b of sorry, a comma 2 comma 10. This is the second partition. Next here c again 2 comma 15 and 25. Next coming to a we have 2 comma 25. Next to b we have 2 comma 30. This is what we have, guys, here. So let's write in the next step here. So from the first partition, what is that we are going to get here? A comma. So the function whatever we have written here, now this function will be applied on the what? The values here. The values. Got it? Values. So what is that we are trying to do now? We are trying to add the values x plus y. We're trying to add the values x plus y. So 2 plus 10 plus 15, that is going to give the result as 27, isn't it? And b gives the result as 2 plus 10, 12 plus 20, 42, not 40, sorry, 32. Okay, the second partition we will get the result as c comma the 2 plus 30 here. This is 32. Next for a, it is, what is the value here? 2 plus 30 plus 20, that will be 52, right? Next for b, it has to be 12. 2 plus 10, that is going to be 12. For p3, the result will be c comma 42 and a comma 27 and b comma 32. And now the the data will be grouped here across the partitions. Now within the partitions, grouping is done and the computation is also done. Function is also applied within the each partition. Okay. The next thing is the data will be grouped in across the partitions. That is 27. Next in the second partition we have 52, and in the third partition we have again one more 27. And coming to B, in the first partition we have 32, second partition we have 12, and third partition we have 32. And in for C, the second partition we have 32. We don't have anything in the first partition, so second partition we have 32, and third partition we have 42. Okay, now the function will be applied on each partition again on the grouped values. Now the function will be applied on the grouped values again. So a comma 27, 52, 27, 54 and 52. It is some 106, I think, isn't it? 106. Next B, it would be the 64 plus 12, 76, and this must be C comma that is 74. This answer that. A106, B76, C74. Just verify this. A106, B76, C74. This is how we are getting here. Just observe here what's happening is the key, whatever the is not key, sorry, zero value. How the zero value is getting involved in this. Okay, this is the fold by key operation, guys. Is it clear with fold by key for everyone? Any questions here?
No.
Okay, right.
Clear.
Now what? Yeah. Now what I do is see here 2.3. I use 2.3 here. Just see what happens here. So what happening here? 2, 3. That means integers. It is getting added with what? 0.3,
Mm.
2.3. It is getting added with. Instead of integer, we have taken here what you call as double value. Actually, it is
Float.
going to be taken as float. Actually, yeah, it is going to be taken as float. Okay, so the float can be added with integer, so we get the result corresponding to that. That's fine. Okay, now the next function is aggregate. The last one in our discussions, just aggregate. And here, let me write the comment here. F1 will be applied on the values same within the partitions and across the partitions. And for the next point, again one more point, that is zero value also included. It also will be included in the list of values, the list of grouped values. This is what you need to understand. Here we don't have zero value. Here we have zero value. We will see the purpose of this zero value actually, guys. Here, just wait for this some time. We'll understand actually what is the purpose of it actually. Next, we go to aggregate by key. So pair RDD dot aggregates by key. What is syntax, guys? Do you remember syntax? Zero value, first function, and second function. We pass two functions: zero value, first function, and the second function. Okay. What's the difference, guys? Here between uh, the fold by key and this one? The only thing, very simple here, it will be same as fold by key. The only thing is F1 will be applied on the within the partitions, applied on the values, on the grouped values within the partitions, okay. And what about F2? F2 will be applied across the partitions, and zero value will be included. Okay, that is by default, that will be there. Two functions will have, one function will be applied, so the same function will be applied within the partitions and across the partitions. But here we can apply two different functions within the partitions and across the partitions. Got it? Now this is very simple. We can write like this: result 3 equal to R1 dot aggregates by key of, we need to pass some zero value here, 2 comma. Next, what is the second element? So first we need to pass one function, right? So lambda x comma y. This is the first function, so I'm using f1 of x comma y. Next, lambda of x, second function, x comma y. So what is x comma y second function? I will use here. Let me create one more function here, df some f2 x comma y. It is taking two values and return x minus y. Let's say x minus y. Now I will use f2 of x minus y. Let me use for now f1 only, f1 of x comma y. I will let you know what could be the problem with this. I will show that now. Print, sorry, print res3 dot collect. Okay, some issue, some error here. What is that? RDD aggregate spelling, RDD aggregate. Yeah, we got it, guys. The same result that we got with that fold by key. Why we have used the same function. We are using the same function within the partitions and across the partitions. So this would be same as fold by key with this value. So here, if you supply to here, we got the same result. Okay, if you see here, we got the same result here and here. Why? Because we are using, it is said that f1 will be applied across within the partitions, across the partitions. Here we are using intentionally the same function. Two functions are same. F1 only, we are using f1 the two function. That's the reason we got the same result. Okay, if you want, we can use a different function here. So x minus y, now I can use f2 of x minus y. Now the result will be computed differently. Yeah, okay. Now next thing, I place 2.3 here or 2.5. Okay, I'm changing to f1 only, guys. Just observe here, I'm changing to f1 here. I'm changing to f1. Now what I do is 2.5 and Python. Sorry, I am writing here Python. What's the error here? Cannot contain a string and int objects is not supported actually here. So it must be integer or string, integer or some what called as float only. It cannot concatenate a string like this. Now we are able to perform addition and subtraction, all this. Okay, now the thing is something like this, guys. My requirement is something like this. That is, now you understood the purpose of all these functions. Now can you tell me, I would like to find out the average of each key. Here we are getting, here we are getting the sum, right? Here we are able to get the sum here. If you take 0 here, what is going to be? It is going to be, if you're taking 0, this is the addition of only those elements, addition of the keys. So correspondingly we got 100, 70 and 70. Got it? Now my requirement is, I need to get the average of this B. That is 70 by the total number of elements, 100 by total number of elements, and 70 by total number of elements of C. How many are there? How many A's are there here totally in all the partitions? You see here, how many A's are there, guys? Here 1, 2, 2 in the first partition, 3, 4, 5. Total we have 5. So 100 by 5. I have to get the result as 20. A comma 20. I have to get the result as A comma 20. And next, for B, how many elements are there? 10, 20, sorry, 1, 2, 3, and 4. Okay, so 70 by 4, I have to get that result. And for C, again 70 by some 3 or 4, I have to get that result. How do I do that? So you understood reduce by key, fold by key, and aggregate by key. Now can you tell me which function we can use to perform the average, to get the average of each key, that is sum of the number of Sum of the values by total number of values, sum by number of values. How do I do that? So you got the idea of three functions now. So you have pen and paper with you, just to look at that and try to check out if that is possible with any of these three functions: reduce by key, fold by key, and aggregate by key. Please take few seconds. You can take 1 or 2 minutes and try to tell me which function we shall use here. Narendra, are you there?
Hello.
Group by
Yeah.
reduce by
Reduce by key. Okay, sorry. So can you tell me how to do that? Reduce by key. R1 dot. Sorry, something happened here. R1 dot reduce by key. Can you tell me, Managna, here how to do this? Lambda of x comma y colon
Aggregate by key only you can pass two functions, right? First we'll combine all the values, then we need to apply second function. Second function.
Can you tell me that? I will try to.
That also difficult, sir. Again, because it will add all the values, and then how to pass the elements, that is difficult.
The thing is,
Okay,
we have to find the number of elements, number of values.
Not possible aggregate by key also. Then combine by key only. Maybe we don't know the functionality. Maybe that one we can.
Just try. Let the others try. Just try to see, guys. We'll try. I will try to go with your answers. Later, I will go with the combined by key. Sweta, Varshini, Hari. ఎట్లా రావాలి అంటే actually what is the requirement is, see this first. ఇప్పుడు ఇలా this is the first partition data, right? For this output ఎలా రావాలి అంటే a comma, okay, a comma 1 2, how many a's are there in this? How many a values are there? రెండు ఉన్నాయి కదా ఇక్కడ, 10 and 15, 2 was there, right? So I need something like this, 1 comma 1 and 10 comma 15. You got this? What is this 1 comma 1? 10 15 వచ్చేసి values కదా, these are the values. 10 and 15 are the values of a. What is 1 comma 1? There's nothing but we are trying to count the number of values. అంతేం లేదు. We have to get the count of the number of values, right? We have to get the count of the number of values. A 1 comma 1 and 10 and 15. Got it? And similarly to B also we have to get something ఇలా మనకి ఇలా వస్తే చేయొచ్చు అని చెప్తున్నాను. 1 comma 1 also we have values 20. Okay, otherwise I will write below here all this ఇక్కడ కింద రాస్తాను. It will be fine. For the next second partition ఎలా రావాలి చెప్పండి. For C, how many values we have? We have only one, so we have to get 1 comma 30. This is about C. And for A again, what we need to get? We have two values again, 1 comma 1 comma, what is the values? 30 and 20. ఇట్లా రావాలి యాక్చువల్గా మనకి, ఇట్లా వస్తే చేయొచ్చు. B we have only 1 and 10 is the value. Next, coming to the third partition, C, we have 2 1 comma 1, next 15 and 25. Next we have A, we have only one value of A, that is 25. Next B also we have only one value, that is 30. Got it? Fine. Now ఇట్లా అయిన తర్వాత డేటా ఇలా గ్రూప్ అవ్వాలి. అర్థమవుతుంది కదా, ద డేటా హ్యాస్ టు గ్రూప్ లైక్ దిస్. ఇంతకుముందు ఎలా చేసేవాళ్ళం? సీ హియర్, ద ఓన్లీ డేటా ఈస్ గెటింగ్ గ్రూప్డ్ హియర్, ద వాల్యూస్ ఆర్ గెటింగ్ గ్రూప్డ్. బట్ వాట్ ఈస్ దట్ రిక్వైర్డ్ నౌ? We need to group the values as well as the number of values also. ఎలా రావాలి మనకి రిజల్ట్ అంటే A comma 2 and 25. Got it? A of 225. Next B of 2 and 30. అంటే every key should have the sum of the values as well as the number of the values. Are you able to follow guys here? ఇది ఎలా ఇంప్లిమెంట్ చేస్తామని విల్ సీ దట్ లేటర్. బట్ వచ్చేసి ఎలా మనకి వస్తే మనకి రిజల్ట్ వస్తుంది అనేది వీఆర్ ట్రైంగ్ టు సీ దట్. ఓకే, అండ్ సిమిలర్లీ హియర్ వాట్ డు వి గెట్ హియర్? C comma 1 and 30. This is done. Next for A, 2 and 50, and for B we get only 1 and 10. This is the result we have to get from second partition. Next, from the third partition, what is that we have to get? We have to get C as, sorry, first C as 2 comma 40. Next, again A comma 125, and for B we have to get 1 and 30. This is what we are expecting at partition, within the partition jarigi the output of the partitions to be. Got it guys? Is it fine? Okay, is it fine?
Yes, sir.
Right. Next, outside the partitions, what do we need? This is within the partitions guys. This is what we are expecting to be done within the partitions. Okay, now across the partitions, what is that expecting across the partitions? And from the first one, in A we have 2 comma 25, and the second element also we have there. The second partition we have 250, 2 comma 50. The third partition we have 1 comma 25. Got it guys? We have 3 elements. First we are doing grouping only, okay, followed by in the second partition B, sorry, for B, not second partition, for B, in the first partition we have B 2 and 30. In the second partition we don't have, we have yes 1 comma 10. Next, in the third partition we have 1 comma 30. Next, in for C, in say first partition we don't have anything. The second partition we have 130. The third partition we have 240. ఇప్పుడు result ఏం రావాలి? What is the function that has to be applied here? Can you tell me please? ఏం జరగాలి ఇక్కడ? What has to be done?
2,25 2,25 values లో సెకండ్ వాల్యూ అన్ని యాడ్ అయ్యి మిగతా బై కావాలి యాక్చువల్గా.
సో అంటే see this 2 must be added with this 2, ఈ 2 వచ్చేసి మళ్ళీ దీంతో 1తో యాడ్ అవ్వాలి. అంటే ఈ ఫస్ట్ పొజిషన్స్ లో ఉన్నాయి కదా, ఈ 2 this 2 అండ్ this 2 ఇవన్నీ యాడ్ అవ్వాలి. ఓకే, అట్ ద సేమ్ టైం 25 50 అండ్ 25 ఇవన్నీ యాడ్ అవ్వాలి. మనకి ఎలా రావాలంటే ఏ కామా, సో 2 + 2 + 2 + 2 + 1 ఇట్లా ఒక ఎలిమెంట్ రావాలి. అండ్ వన్ మోర్ ఎలిమెంట్ ఈస్ 25 + 50 + 25 ఇట్లా రావాలి. ఇప్పుడైతే ఫైనల్ మనకి ఏం వచ్చేస్తుంది, ఇఫ్ విత్ దిస్ ఏ కామా హౌ మెనీ నెంబర్ ఆఫ్ ఎలిమెంట్స్ ఆర్ దేర్, 5 ఎలిమెంట్స్ అండ్ వాట్ ఇస్ ద సమ్ ఆఫ్ ఇట్, 100. గట్ ఇట్. ఇట్లా వస్తే మనకు దెన్ వీ కెన్ డివైడ్ దిస్ 100 by 5. గట్ ఇట్. ఈ 100 దాంతో డివైడ్ చేస్తే వీ గెట్ ద యావరేజ్. గట్ ఇట్. ఆర్ యూ ఏబుల్ టు అండర్స్టాండ్ దిస్ గైస్ హియర్? సో బి కామా నెక్స్ట్ ఏం రావాలి, 2 + 1 + 1. Okay, this is the one element, and 30 + 10 + 30. So we have to get b comma, what is the value, 4 and 70. And next for c we have to get 1 + 2 comma 30 + 40. This should give the result as c comma 3 and 30 + 40 70 ఇలా రావాలి. So if we get the result like this across the partitions, then we can get the average by substituting, by dividing this value with the number of values. Is it clear case? Are you able to understand this? Within the partitions em jaragali, across the partitions what has to be done. కొంచెం కన్ఫ్యూజింగ్ గా ఉంటుంది, but try to understand here. It's very simple. I think this is clear, right? Do you have any questions in this? Please let me know here. This is important, guys. Please try to understand here. Do you have any questions here? So this is what we are expecting. This is the actual data with each partition. See this. For this partition, this is what we are expecting within the partitions. Just go through the data and this data and try to see what's happening there. అంటే ఏమవ్వాలంటే what is that we are trying to do is, while grouping the values, values ని group చేస్తున్నాం కదా ఇక్కడ. If you see here, the values are getting grouped, right? So during the grouping of the values, we need to count the number of values also. Got my point here? Are you able to understand this, guys? While grouping the values, the number of values also must be grouped here. Okay, ఎట్లాగంటే let's say we have 50 30 40 20 ఇలా ఉన్నాయి, 4 values ఉన్నాయి. How will you find the average now? How will you find the average of these?
Sum by number of numbers.
అది ఎలా చేస్తారు? మనం సింపుల్ గా చూసి మనం చెప్పొచ్చు, బట్ యాక్చువల్లీ ఏం చేస్తామంటే దీన్ని ఒకటి అనుకొని 1,30 అనుకొని, నెక్స్ట్ 1,40, just 1,20 అనుకొని, next we group all this 1,1,1,1 and we group these 50 30 40 and 20. ఇప్పుడు యాడ్ చేయండి. 1 + 1 + 1, this gives the result as 4, and this will give the result as some 120 140 like this. Now we can perform the division of 140 by 140 and 4, 140 divided by 4, we get the average of it. అంటే this is what actually that should be calculated, right? Machine చూడంగానే అర్థం కాదు కదా, we have to supply the logic to the program, right? That logic to be provided in the form of a program. So it won't understand, మనకు తెలుసు కాబట్టి we calculate everything in our mind, we give the answer, but it's not like that, right? So actually ఏం చెప్పాలి అంటే, so ఇది ఒక వాల్యూ, this is another value, 3 value, 4th value, 4 values are there, and corresponding to each value we are assigning one value, what is that? 1 అని చెప్తున్నాం దాన్ని చెప్పి we are grouping all them, we are adding them, and this is the 4 values. How many values are there? 1 2 3 4 మనం అనుకుంటాం అట్లా in our mind. Okay, so that is nothing but we are calculating each instance of a value, nothing but 4 values, and we are adding them, nothing but we are getting the result 140 by 4. That is going to give the result. Okay, so do you think it's the same thing happening here? చూడండి ఇక్కడ while grouping the values itself, even we are counting the number of values also. You have to count the number of values. The thing is how to count the number of values. That is the question here actually. How to do that count? ఏం చేయాలి చెప్పండి ఇక్కడ, how to do that count? Yeah, I will show you now. It's very simple. Any guesses guys here? You point at the mind. Just try to tell me first. Did you understand this first? Did you understand this? Within the partition, across the party, what's happening? ఏం జరుగుతుంది అనేది తెలుసా? ఎలా చేయాలనేది చూద్దాం ఇప్పుడు. But are you able to understand this approach or not? Yes, guys, please do raise. Yes, right. Narendra, is it okay? Sravanti, Hari.
Sir. Good.
Right. ఇప్పుడు ఏం చేయాలి చెప్తాను. I will show you now. Just observe very clearly. I will write the detail in detail. Okay. Now. Okay. Now we have 10. ఇక్కడ a కి 10 అని ఉంది. Now we have a of ఎలా, in the first partition how the data is getting grouped. Otherwise I will write here itself so it will be easy for you to understand. A of first element ఏం అవ్వాలి? Here we have 10. Grouping is not yet started. 10 ఉంది ఇక్కడ. ఏం జరగాలి? Otherwise I will write everything first. I will write below. ఇక్కడ కింద రాస్తాను చూడండి. A is there. Process start అయింది. System process start అయింది. What should happen with the 10 now? ఏం జరగాలి? It should be counted as, it should be converted to 1,10. Okay, just observe very clearly guys, observe very clearly. In the first step, Control C, and I'm pasting as ఇక్కడ వచ్చింది. So this is the first partition. A comma 1,10 ఇట్లా ఫామ్ అవ్వాలి. ఇట్లా ఫామ్ అయిన తర్వాత not అన్ని గ్రూపింగ్ జరగలేదు. గ్రూపింగ్ is not yet done. Okay, this is the first step. Second step లో what should be done is a comma 1,10 comma second element must be included. Okay, and we'll have this. Okay, now ఇక్కడ ఏం జరగాలి చెప్పండి? What should happen here? ఈ నెక్స్ట్ స్టెప్ ఏం జరగాలి? What should happen? A comma 1, 10 and 15. This is we have created as 1,10 and second element is 15. What should happen now here? ఏం జరగాలి ఇక్కడ? So this should be done like this. 1 plus 1. Just observe very clearly guys. 10 plus 15. This is what that should happen, and this will be as it is. Next, so this will become as a comma 2 and 25. Sorry, 25. And next we'll have B. No, okay, A, and I'm printing B as it is. Now can you tell me what that should happen with B here? What will happen with same way like we have with here? with A. ఏం జరగాలి చెప్పండి ఇక్కడ B, perfect 1, 10 must be included with 20. Okay, so and I'm writing as it is here 2, 25, and for B ఏం జరగాలి ఇక్కడ 1 plus 1, 10 plus 20. Got it? That's it. A, 2, 25 and B of 2, 30. Got it guys here? 2, 30. So by the end of this process, did we get the number of elements of A in the first partition and the sum? And with this we got the number of elements of B in the first partition and the sum of it. Got it? So just observe. So this is end of process in one partition. ఒక partition లో the same thing has to be repeated in all the partitions, isn't it? ఇక్కడ ఏం జరిగిందో the same should be repeated in each partition. Got it? In each partition. So see the first step ఏం జరుగుతుంది ఇక్కడ. This is the first step. Just leave about this B, first concentrate on A. For each key what's happening, just observe here. So ఒక value ఏమవుతుంది, a value must be converted into what is this called as 10 ఒక value కదా, it is an integer. It must be converted into a pair, right? A pair, a tuple, a pair or a tuple, 1 and the value వచ్చేసి it must be converted to 1 and 1 comma value. Okay, and second step లో what's happening here, we're trying to group again. That is grouping ఎలా జరుగుతుందంటే 1, 10, this is a tuple is getting merged with what, a value. ఒక tuple ఒక value తో merge అవుతుంది. Got it? So how it is happening, the 1 is added with 1 and the values will be added. So let me show you that now. How we are going to write this, just also very clearly. df, I'm writing some functions here. fn1 x. So what I do is I will do one thing instead of make confusion here. Some r3 equal to r1 dot map of lambda x colon float of x. What is this guys? What is that I am trying to do here? ఏం లేదు, typecasting, right? What's the problem? What is the error here? Sorry, each is a sorry each is a error, PairRD, right? So x of 0 will be as it is, float of x of 1, float of x of 1 in a bracket miss అయింది ఇక్కడ. Just we're typecasting to float. Confuse కాకుండా I've written like this. Okay, that's fine. Just observe very clearly guys. df function 1 x. So ఇక్కడ ఏం జరుగుతుంది చెప్పండి. ఫస్ట్ ఇక్కడ వాట్స్ హ్యాపెనింగ్ హియర్, ఈ వాల్యూ అనేది ఏమవ్వాలి, it must be converted as a tuple. Got it? ఒక వాల్యూ must be converted into a tuple, 1 comma tuple లో కన్వర్ట్ అవ్వాలి. Okay, so we are doing the same thing here. Assuming x as a value here, what is that we have to return? What is that we have to return?
Return 1 comma x.
Perfect, we can 1 comma x. This is about the first thing. Okay, next second function, see here, fn2 of here in the second step, what is that we are doing here? ఇక్కడ ఏం చేస్తున్నాం, what is that we are trying to do here? We are trying to take, what are the two inputs here? One input is a tuple, another input is a value, right? One input is a tuple here and another input is a value. Got it? Okay, so the same thing here. So I'm taking x comma y here. What is x here? X is tuple and y is a value. Okay, Now what ఇక్కడ ఏం చేస్తున్నాం చెప్పండి, what is that we are doing with between these two? You have to tell me guys, you have to tell me the logic. That is, the first element of the tuple is getting added with 1, okay, and the second element of the tuple getting added with the value. అంటే ఇక్కడ ఏంటి అంటే x equal to 1 comma 10 ఇక్కడ, and y is equal to 50 or 15 అనుకుంటే, what is that we have to write now here to return this as ఈ రిజల్ట్ రావాలంటే ఏం చేయాలి? What is that we have to return? X of 0 plus 1. Do you agree with this? And x of 1 plus y. Antena?
Yes.
X of 0 plus 1, x of 1 plus y. The same thing right here. So return x of 0 plus 1, comma, put it in a tuple, and x of 1 plus y. Very simple. Okay, this second function. Okay, now fine. After this, just to see here. Now see the part across the partition. This is within the partitions done. Across the partitions em chestunna. What is that we are doing across the partitions? This is one element. This is one element. This is one element. Now what is that we are doing now? Chepandi ipudu. What is that we are trying to do? One second. Control C. I will write it here. Just over guys, just 2-3 minutes and then అయిపోతుంది. For maximum 5 minutes. Now this is the results of the partitions guys. After the actually otherwise, yeah, let me compute for this. Put data ఇలా ఉంది. After the across the parts, the data is like this. Now what is that we have to do? What is the first step here? దీన్ని చెప్పండి, దీనికి ఏం చేద్దాం చెప్పండి. సో ఫస్ట్ 2 ఇన్పుట్స్, x ఇక్కడ 2,25 అనుకుంటే, if x is equal to 2,25 and y is equal to 2,30, ఇక్కడ ఏం చేయాలి చెప్పండి? What should be the output here? ఇక్కడ ఏం రావాలి? x of 1, x of 0 plus y of 0, and you can write like this, x of 0 plus y of 0 ఇది ఒకటి, and x of 1 plus y of 1. ఇట్లా రావాలి. The same thing, right? So you return the same thing here. So def function 3 x comma y. So what is x and y here? Both x and y are tuples here. Got it? So what is that we have to return here? Return x of 0 plus y of 0, comma, x of 1 plus y of 1. Got it? Return x of 0 plus y of 0, x of 1 and y of 1. It's very simple, right? Now think is result. This is something like this. Now result 4 equal to R3. I'm taking R3 here, R3 dot. This one I'm taking this R3 as the input. R3 dot combined by key of pass these 3 functions, function 1, function 2, function 3. And print res4 dot collect. Yeah. Let's see this guys. What did we get now here? B 470, A 500, C 370. Did you get the number of elements, number of values, and sum of the values here now? Are you able to see this?
Yes.
Yes. So simple 2-3 steps లో అయిపోతుంది, but see the complexity involved in the back end, how to understand this. దీన్ని ఎలా అర్థం చేసుకోవాలి అనేది their actual life efficiency. So if you understand the flow and framing of these functions, if you know how to frame these functions, it's very simple. Otherwise, it will become very tough. Okay, so this combined by key will accept 3 functions, yes, and each function will have its own importance. How to frame the values here, and how to aggregate, how to group the values, and how to group the values at partition level, across the partition. This is at partition level, and this is at the across the partitions. Okay, the syntax is like this, guys. What is syntax of this? Some PairRDD dot combine by key of function 1, function 2, function 3 functions will be applied. Can you tell me the purpose of first function and second function and third function? Second function F2 will be applied within the partitions, and F3 will be applied across the partitions. Then what about the function 1? Function 1, what function 1 is doing here? It's creating a pair out of a value, This is nothing but generation of, this is important, guys, generation of zero value from a function. This is same as the sum one, guys. In aggregate by key or in fold by key, we use a zero value, right? In aggregate by key and fold by key, we use a zero value, but zero value we pass as a static value there. We pass a static value, but here we can generate a zero value. We can generate a zero value out of a function. That can be done with the first function here. So కొంచెం కన్ఫ్యూజింగ్ గా ఉంటుంది, but try to understand here. It's very simple. Just practice this example after the session and try to analyze it. What's happening here? You'll understand very clearly. Not at all a problem. Very easy. Now, can you tell me, guys? We did not get the average. Still, we did not get the average. How to get the average? And result 5 equal to res4 dot map of lambda x. Can you tell me, guys, how do we get the result of it? X of 0, comma. Can you tell me? This is x of 0. In each element, this is the x of 0 is the first element string. How do we find the average of this now? Second element, x of 1. X of 1 is second element, right? The entire second element. The entire second element here. This is x of 1. దాంట్లో మనకి ఏది కావాలి? Again,
X
in
of
that we need the second
1 of
element.
2 by X of 1 of 0
X of 1 of 1 by
by
x
X
of
of
1
1 of
0, right? Print res5 dot collect. ఇక్కడ చూడండి ఇట్లా వస్తుంది. 70 by 4, it is 17.5. 100 by 5, it is 20, and 70 by 3, it is 23 point some 333 values. Got it? ఇలా చేయొచ్చు. It's clear, guys?
yeah. Yes.
You know, if you go with what you call as internet, you find the same example about the combined by key, but they write differently. I did not find any solution in Python, PySpark. They have mentioned examples in Scala, but okay, just go through it. If you have any questions still, I will try to clarify this in the next session. Okay, so the next session, guys, we are going to start the use cases, and my request is just go through the functionalities, right? The transformations and actions we performed on RDDs, data frames, all those. So because you should know when we are performing some operation, you should know why that operation will be used, what is the purpose of that particular operation, transformation or action. Okay, I think now we got some idea about the transformations, actions on RDDs, data frames, and some information about the cluster. Okay, how to deploy an application to a cluster, how to develop application, simple application, how to deploy to a cluster. We got it. Okay, got it, right? Yes, just I'm telling you that some information about RDD and data frames and their corresponding transformations and actions. Okay, we have seen them. And one more thing is we have discussed certain features of Spark, like persistence, the resilience, and what is that, some lineage, stages. Okay, and tasks. We have this OTAS, and next we have discussed about the cluster also. Cluster, what is an executor, what is a driver, and what is executor memory, what is driver memory cores, and how, what is Sparks, when what is the script that we use to write Spark submit. I think we got the basic idea of all these things. Okay, just have a revision of this, all these, all the whatever we have discussed till now, and so that you should not get any doubt while programming or while submitting the application to cluster. You should not raise any doubts actually. Concept wise you have some doubts, but syntax wise or something like that, you should not have any doubts. So, and try to go with some this Python programming also. Whatever the initial sessions we have discussed in the Python programming about the conditional statements and loops, all these. Okay, just go through all these. The basic print statement, if else, loops, and some cases, all these you have to understand this. So if you have idea of all this, then it will be easy for us to develop the use cases. Otherwise, it will become some not difficult actually. Thing is, we feel confused. What's happening? That we could seem confused. Okay, so if you need some 1 or 2 days, take those 2 days of time and revise all this whatever we have discussed till now. Okay, if you do not want any time, if you want me to continue directly from tomorrow itself, I will be continue. Okay, just take a decision, discuss among yourselves, and let me know by the end of the day. Okay, fine guys, any questions still?
Yes, sir.